Why do 90% of us enjoy a hot shower on a cold day? It's all about heat transfer. Let's break it down with a simple example. Imagine you've got a metal rod, with one end in a pot of boiling water and the other in ice water. Heat flows from the hot end to the cold end. But how fast does that heat move? Here's the formula: rate of heat transfer equals thermal conductivity times temperature difference between two ends times the area of cross-section divided by the length. So, thermal conductivity is like the rod's superpower of conducting heat. The bigger the temperature difference, the faster the heat transfer. The area of cross-section? That's how thick your rod is. And length? Well, that's just how long the rod is. So next time you sip that cooling coffee, remember it's all about heat transfer at work. Physics is everywhere, folks. Stay curious and keep learning. I bet you didn't know that your morning toast is a science experiment in disguise. Let's dive into conduction. So conduction is a fancy word for heat traveling from one thing to another. Imagine you're making toast. When the bread touches the hot toaster, heat moves from the toaster to the bread. Simple, right? This happens because the toaster's heat makes the bread molecules move faster. These fast-moving molecules bump into slower ones, spreading the heat. Think about when you touch a metal spoon in a hot pot. Ouch! The spoon gets hot because heat travels from the pot to the spoon and then to your hand. Metals are great at conduction. They pass heat along quickly, but not everything conducts heat well. Ever notice how wood handles on cooking pots stay cool? Wood doesn't let heat travel through it easily, protecting your hands. So next time you're toasting bread or cooking, remember, you're watching conduction in action. It's how heat gets around, one bump at a time. Catch you in the next video. Got a hot cup of coffee? Here's how that heat travels through your drink. Convection is all about heat moving through fluids. Think water or air. When you heat up soup, the bottom gets hot first. That hot liquid rises to the top and the cooler stuff sinks down. This creates a cycle. Same thing happens in the air. Warm air from a heater rises, cool air sinks, and the room gradually warms up. It's why your hot coffee cools down. The heat moves from the hot liquid to the cooler air around it. So next time you feel a warm breeze or see bubbles in boiling water, you're witnessing convection in action. Cool, right? Or should I say warm? That's convection, nature's way of making sure the heat gets around. Simple and efficient. Am I the only one that didn't know why a toaster glows red hot? Let's dive into black body radiation. Alright, so black body radiation might sound fancy, but it's super cool. Imagine you have a toaster. When you turn it on, those coils inside heat up and start to glow red. That's black body radiation in action. Basically, any object that gets hot emits radiation. The hotter it gets, the more energy it gives off, and the color changes. Starts with red, then can go to white, and even blue if it gets super hot. Scientists use the term black body to describe an ideal object that absorbs all radiation and reflects none. So it's perfect at emitting radiation when heated. Our real-world objects like the toaster come pretty close. In short, black body radiation helps us understand how objects emit light and heat. So next time you see that glowing toaster, you'll know it's not just breakfast magic. It's physics in action.